The night sky, a vast canvas of stars, has captivated humanity for millennia. We gaze up at the twinkling lights, wondering if we are alone in this vast universe. This curiosity, this primal urge to explore, has fueled our dreams of space travel and living on other planets. Imagine standing on the surface of Mars, the red dust crunching beneath your boots as you gaze at a sky painted with the colors of a Martian sunset. Or perhaps you envision yourself on an exoplanet, a world orbiting a distant star, its alien landscape teeming with strange and wonderful life. The possibilities are as limitless as the universe itself. For centuries, science fiction has tantalized us with tales of interstellar voyages and alien civilizations. But now, we stand on the cusp of turning fiction into reality. Advances in space technology and our understanding of the cosmos are bringing the dream of space colonization closer than ever before. Earth, our pale blue dot, is finite, its resources dwindling. To ensure the future of humanity, we must look beyond our home planet and venture into the great unknown. The challenges are daunting, to be sure. The distances involved are staggering, the environment's hostile, and the resources scarce. But the human spirit is one of resilience, ingenuity, and an unyielding thirst for exploration. The same spirit that drove those achievements will propel us towards the stars.
The journey will test our limits, challenge our assumptions, and ultimately redefine what it means to be human.
When we envision life on other planets, Mars often comes to mind. Our celestial neighbour, with its rusty red hues and icy polar caps, has long captured our imagination as a potential second home for humanity. While Mars may seem like a barren wasteland at first glance, it holds tantalizing clues of a potentially habitable past.
However, Mars is not the only candidate in our search for a new home. Scientists have discovered thousands of exoplanets, planets orbiting stars beyond our solar system. Some of these exoplanets, known as Goldilocks planets, reside within the habitable zone of their stars.
These distant worlds offer a tantalizing glimpse into the possibility of finding life beyond Earth. Imagine a future where humanity becomes a multiplanetary species, with colonies on Mars and outposts on the moons of Jupiter and Saturn. Each of these worlds presents its own unique set of challenges and opportunities.
We need revolutionary advancements in propulsion systems, spacecraft design, and life support systems to make interstellar travel a reality.
The vast distances between stars pose a significant challenge for interstellar travel. Even at the speed of light, a journey to our nearest stellar neighbor, Proxima Centauri, would take over 4 years.
One such concept is the warp drive, a theoretical propulsion system that could distort the fabric of spacetime. While warp drives remain theoretical, the idea has captured the imagination of scientists and science fiction enthusiasts alike.
Another approach to tackling the time problem of interstellar travel is cryosleep, or suspended animation.
Advances in cryogenics and our understanding of human biology are bringing this futuristic concept closer to reality.
We need to develop self-sustaining spacecraft capable of supporting human life for extended periods.
These spacecraft would need to be self-contained ecosystems, generating their own oxygen, recycling water and waste, and even growing food. Imagine stepping out onto the surface of Mars, feeling the crunch of red dust beneath your boots.
One of the biggest challenges of living on other planets is creating a breathable atmosphere for humans. One promising approach is terraforming, the process of transforming a hostile planetary environment into one suitable for human life. For Mars, this would involve thickening its thin atmosphere and warming the planet to melt its polar ice caps.
While terraforming is a long-term goal, we can create smaller-scale enclosed habitats in the meantime.
These habitats could range from inflatable modules to underground caverns, shielded from radiation and meteoroids. Inside these habitats, we would need to create closed-loop life support systems that recycle air, water, and waste.
These closed-loop systems would be essential for long-duration space missions and permanent settlements on other planets. Future space habitats will likely incorporate bioregenerative life support systems, using plants and algae to recycle air, produce food, and purify water.
Imagine growing your own food on Mars. It's not just about survival, but thriving in a new world. We could use advanced hydroponics and aeroponics to cultivate crops without soil, utilizing minimal water and maximizing efficiency.
The journey to the stars starts with the first step, and that step is Mars. We've already learned so much from the International Space Station, but Mars presents new challenges and opportunities. Each mission brings us closer to making humanity a multi-planetary species.
As we stand on the brink of this new era, the dream of living among the stars feels more tangible than ever. The innovations and explorations of today are laying the groundwork for the thriving communities of tomorrow. We are not just visitors in space, we are pioneers carving out a new chapter in the story of human civilization.